Okay, I really need to record and talk about some stuff because this is what's going on lately and it's really interesting. So I started measuring angles and here, let me pull it up. Steam it. Wrote an, wrote an article, made a video, didn't really talk about it much. Angles of the world, angles of Mount Girnar, something like that. Girnar. So I did this I've shown in the past, but new stuff is kind of going on. So I noticed. So maybe I can talk over this and explain this a little bit. If I can increase the size, cool, and it even naturally moved it over to the side. Okay. So I tried to measure generally from this straight portion, like once the bend straightened out, to this straight portion once the bend straightened out, and it's around 90 degrees. That's interesting. Over here, so this straight line across the center of the mountain is exactly east-west. It has four openings at the north, east, west, and the south portions of the granophyre ring, microgranite ring surrounding it, this ring of mountains that's most prominently visible here. But it has openings at precise points and the shape. So I've been kind of like, this looks like a crystal. The more I look at it, the more I'm like, this literally is a fucking crystal, dudes. Maybe I should pull up my Twitter then in that case. Just hop around a little bit real quick. Uh, let's see. I'm going to show this for sure. Also interesting. I mean, want to know what the innards of the earth looks like? At least from a different angle. This is some kind of structures in Africa. So I started looking at Africa, but I don't want to get too off track. So see, I'm just looking at angles, and I started looking at Africa because, see, to the point where I started literally numbering. I numbered the angles. I was like, okay, there's like distinct-ish angles here. Like if it just kind of bends, a gentle bend, it just kind of bends. But if there's a sharp turn, then like down here, there's a sharp turn. So there's an angle there, and really like here, those are obvious, but like there's lots of them. There's one here, all over the place. To the point where I was like, maybe I'll just measure them all, and if they're like let's say I measure 40 of them and half of them feasibly, and I show it, like, because I fucking make sure it's like overlapping as best as possible and being honest about the process, and like, how many of these are about fucking polygonal angles, not just like 129 degrees or 100 and whatever, but like 45, 60, 90, 120, 135 I've been seeing a lot of, which is the opposite of 45 and a 180 degree. So, makes sense. Although I did not expect that one. I was really just looking for 120s, and because 135 visually looks like 120, I was just, in measuring them, I was like, a lot of these are around 135. That must be, let me think, 45, that makes sense. That's why, because there's some polygonal thing going on. What was I doing? Oh yeah, crystal. Yeah, like this right here. It's got a straight peak, and then ridges that maybe branch out at 90-degree angles. A straight peak, 90-degree angle ridges. So I measure these. I'm measuring the angles. So it's a little hard because I didn't do anything. People looking at this are like, well, what are you measuring here? Well, I'm measuring, like, there's a ridge. If you look, there's a fucking ridge. See it? See this ridge? I'm measuring this from off of. So I aligned one of this. How I did this was I aligned one of them with one thing, and then the other I aligned with the other thing, and then I just kind of positioned it over top them and said, therefore, the angle is this. And that's kind of how I approached it, especially when it was not apparent, like, where the corner was. Like, okay, this side is here, this side's here. Okay, let's just figure out doing it that way. But, like, when it's close up like this, it's kind of hard to see what's going on. So, like, here, there's that ridge. And then initially, what's interesting, this ridge over here initially comes off at a 120-degree angle from this ridge. But then, which also the first ridge starts at a 90-degree angle and then bends 30 degrees to be at a 120-degree angle, where the other ridge starts at... Did I skip it? I must not have this in good order. It starts at 120, and then it bends 30 degrees off to 150, and then it comes in at a 90-degree angle with this structure here, which is exactly, look at the angles. Wait, where is it? Here. 124.3, 179.7, 55.4, along that line. 124.3. I did not change it. I just physically moved the map and repositioned this over top this line, and it was exactly... Like, why? Guys, geology doesn't care. It's like, oh, happenstance, coincidence. Erosion plus time plus coincidence equals that. Are you serious? That's the best. We're gonna accept that as the best explanation. Well, let's keep looking because it's fucking... So my thoughts are, this is a crystal, and over here is an offshoot. This is real interesting. It's like a second system that fractured away at a 90-degree angle in some way. Like, it fed at directly a 90-degree angle. And then I saw this recently. How do nanoparticles grow? Atomic scale movie upends 100-year-old theory. Observe nanoparticles. Look at this. It's got an outer polygon, right? And then an inner blob that's like a circle. So maybe it's not as structurally sound as a polygon, like its sides are. And then interestingly, this inner one absorbs this one, and it goes from a hexagon, and then like this side and these sides start to merge in some way. Like, this is gonna basically, if the video were to be extended, probably this would just become one structure without this gap, and this top would become part of this top. But notice this shape also. It begins a hexagon and it begins to become a triangle. And Mount Girnar is fucking so fascinating. I don't know if I have it here, because this is just straight angles. Look at these angles. Oh my god, this peak, guys. Highly recommend just looking at these images. Oh my god, I literally just went through, look at all these sources. Just been watching Girnar videos and like clipping nice shots of Datatreya Peak. Pardon me, Datatreya. How dare he? This is the side of it. It's real fascinating. This is one of its sides. It looks like this, but right there is just this drop off. Boom. 45-degree angle, 60-degree angle, and then just all over it. And people are like erosion. So I asked the geological community in Reddit to a point where they answered me enough to say erosion and coincidence. Okay, whew, I got that out of someone. It's real hard. It's hard to get an honest answer because they know I'm like, your answer ain't good. You know, I'm pointing this shit they don't even talk about yet. So like, to see it, they're like, "Why are you talking about this? We don't talk about this. You can't talk about what we don't talk about." Obviously, you're just trying to say some shit, and well, blah 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 blah. But let me pause here, because in the Dwarka video, which is so dudes, generally speaking, the details are a little more clear if I play this. Let me really slow it down. I think. So it's. Mind you, the Pacific Ocean does not exist. This does not exist yet. This is an inference that we just. It must exist. Because we have oceans, so there must have been oceans then too. Uh, like what's not going on here is they're not connecting this side with over here. Like it's all closed. It's one single landmass. The Earth was like this, but only like this. There was no ocean like this. This is just a best guess. There's literally no evidence to support this, except for it's a best guess. Okay, because the reality is the Earth expanded from a single landmass. And so what's really telling here, and if you watch my video, I didn't see this, but you gotta understand, I don't know all the evidence yet. But when I encounter it, I'm like, dude, it just proves it. So let's go back. See, so what I say, let me just, before I go into this, what I say because I basically went off of the crustal age. I just was like, based on the crust, ergo, this is how it happened. And so the crust, the oldest crust, is really only in the Mediterranean. And then it immediately is younger, more down in this range, when we enter into the region between North America and Africa. And so I said, well, therefore, the fracture of the Earth expanding began with a crack coming this way, and then down between North America and Africa, and then cutting across between South America and North America to basically into the Pacific, which was not yet formed, to then cause this explosion of the Pacific into basically everything that we see. And I don't really go into detail. Like I didn't mention this at all. I really didn't talk about anything but like this stretch of the fracturing. But it was sufficient where I didn't feel like I must go into all details, because people have to understand I literally can't. I cannot. I can't. There's literally infinite details. Like, what do you want? So like I felt it was sufficient evidence to just say it, and now I'm looking into things and I'm like, okay, here's some more shit. Pardon me, pardon my français. Uh, some more evidence, some more supporting things of what I was saying. Where it basically goes this way, this way, this way. So let's look at what they do right here. So they Mediterranean through between North America and Africa, which is what I said, and then I said the Central Atlantic Magmatic Province basically started to release magma into this region, and then water began to flood out this way, largely, at least this way. And then I said it basically it turns abruptly here and cuts this way. So we're going to start going back in time. This is 200 million years according to radiometric dating. Mind you, this all happened when Dwarka was attacked by a vortex weapon, which caused all of this. And so, you gotta watch my other video if that doesn't make any sense to you. What did he just say? I was listening along. This seemed like a traditional video. After all, he's just talking about the Earth. Now he said something about a vortex weapon on Dwarka, was it? Yeah, so the vortex weapon, it caused the fracture from Dwarka. So here's Dwarka. But mind you, this is closed up, so it's really like this is closed up. This is up here. It's where it is now. It's where it is now. Basically, like India is attached up there. Um, uh, yeah, so India's attached over here. Fuck's sake, I literally can't. And then they attack. They attack with a vortex weapon, which then it begins to travel. What I said in the video was there's some sort of structure to the Earth that has like a golden spiral to Africa, and there's certainly bends that are not so spiral-like and more like polygonal bends. But that is yet to be investigated when I say that. So I just basically say it's kind of like a spiral. So it travels, the energy travels along this spiral, the golden spiral of Africa, and around it towards its center to wrap in. But because it doesn't have enough energy, it deflects away and goes towards over here because the vortex weapon that's attacking Dwarka caused ether to be funneled through the planet and out the other side. And so there's like a weak point over here. Whereas here, as I discussed in the video, is essentially where the nucleus of the crust of the Earth is. So it's kind of like the core of the crust. Not the core of the planet, but the core of the crust is there. And so it could have gone in there if there was enough energy to change the core of the crust to cause it to react. It would have instead it would have gone into the core and exploded the core into basically, instead of creating an ocean floor with cracks, it would have pushed the land outward and just filled it with magma. So it wouldn't have created oceans. It would have just been more like Venus, where it's a single landmass still, but filled with like new rock, not releasing. Anyway, but because it didn't, it went off this way. So that's what I said. So let's just keep watching. real slow speed because shit starts to happen. 200. Okay, so immediately something. I did not really in any way. Not that it doesn't. It just adds detail. So what this does is we see now. It branched this way. So it comes out of the Mediterranean and splits downward at Atlantis. This is where Atlantis was, and even looks like it might have gone around it. If this, I don't know how good these lines are drawn. I still am pretty sure it's Flemish Cap, and remnants exist in the Azores Plateau. Although I may be mistaken, and it may just be Azores Plateau, but I really don't think Flemish Cap has been investigated sufficiently because people just aren't considering the expanding Earth process of it. And I mean, we can see it's kind of at the Straits of Gibraltar. I think it's there. Is it there? It's pretty close. I mean, anyway, so this goes up this way too. So it's split. So it's almost like this part of what was happening, I think, was because Atlantis was kind of just abusive of humans. It was gods abusing humans and like in pride creating this like city where they just crossed lines that were just not fair. It's really truly like modern day equivalent would be an old person like 70s dating a 12-year-old. It doesn't make any sense in terms of the like gap. And so when it happens, it's kind of like not good. And because they're gods doing it and know better, they fucking know better. It literally leads to like a split in the society where like Atlantis, we don't know much about it. We know lots about Dwarka and these things going on, although it's interesting. Dwarka was attacked in the process. I really wonder if it's because Krishna had 100 wives or something, things of that nature. Things that are just like, we're getting a little out of balance, guys. Sure, they're gods, truly. Because we're God and they tap their potential, that doesn't mean they got some fucking imbalance going on where it's like, guys, we're still all equal, so we all should be like equals. Not that imbalance. I mean, sure, ladies love the gods. I mean, look. It's probably hard. That's the thing, is fucking hard. It's hard when the equilibrium of the environment is not stable. Like if everyone's at an equal state of mind of understanding and not being susceptible to being taken advantage of, then there's no like weakness in the structure. But if there's a huge disparity, uh, difference in the consciousness and the people with the like far greater awarenesses, dense awarenesses, because subtle awarenesses are present in the younger, perhaps, due to just the energy of things being at balance always. But maybe there's that side of things too, where maybe it's just deserved and it's the imbalance comes from the dudes pick your fucking game up. And that's your problem, bro. Okay, so it splits and then boom, still fitting along with what I was saying. So I mean, here, so what they generally see, notice it's very weirdly depicted. It's like, what's going on here? Because the portion down here is missing because it really wraps around. I don't think it's long enough. In the video, I say Chicxulub is like here. I don't think it's actually long enough to reach there. It may have been more like here, which is actually, if we go to the map, it may have been more like specifically right here. Let me show you. Maybe it's better that way. Right here. I'm not sure if that measures more appropriately. It's just this. This is 120, so I started measuring angles. So like this is kind of what I did. See that over here, we can kind of see over here it has a straight like boundary. So I put that one there, and then over here this looks pretty straight, like it kind of stabilized. So we'll just go like that, and then like boom. Okay, that's not good overall. So that's part of the thing with drawing angles. Like I start like if I want to make it 120, like I can certainly just be like, boom, whoa, look at that. I mean, it's kind of 120 though. It's in that region where this is kind of 120-ish, but more distinctly 120 is actually over here. See, this chain is much more distinct. It doesn't have that wide spread to make it a little less apparent. So we can do the same thing I just did. I mean, it's hard because it's a globe to truly overlay. So sometimes if it's really straight, to make sure it's appropriate without the curvature of the earth coming into play, I'll just try to make it like here, that's smaller. Whereas, see, like look at that. I mean, so then we can zoom out a bit and just overlay it still. I mean, it still overlays really well. It's literally 120 in stone, dudes. This is common, so maybe this is a good moment to mention right here. I believe it is this one. Yep. Dutch Cincy. Someone referenced this video on my video called Earth from a Different Angle, my last video. As of me recording this, that I've published at least, where I basically just showed angles around, especially around Africa and around Australia. There's just a lot of anomalously, like, vibrationally the same angle, maybe. Maybe that's a good way to put it. It's like vibrationally the same angle, where there was like a consistency to the energy flow that caused the bends to be consistent versus random, like 135, 135, 135, 135 around the south of Australia, 120, 120, 120 around Africa. Like, there's a reason. But this video, they pointed out, I won't play it, but he pointed to a structure that he certainly is correct in pointing out. And oh my, whoa, look at that. Would you look at that? It's literally at the same, see, that's interesting. It's the same angle as this angle. That's interesting, right? Coincidence, guys? At what point do we stop saying coincidence, though, right? So let's go back to here. Identical. Fucking identical. But now, I don't know. Sometimes it does this. I don't know how to... Oh my god, stop it. Okay. Okay, here we go. So we're gonna zoom in a bit. Okay. And then I'm gonna put it right here. I think I got a 45-degree angle real precisely when I did this. Wonder why it's not doing that now. Maybe I was in real close. I don't know. I honestly thought it would be like exactly one, like Hawaii. I'll come back to Hawaii time and time again. 120. That fucking bend, 120. The one in South, off of the coast of South America, time and time again, not 120. It's more like random, depends on what I choose that time. Because the options, the spread of potentials is more there. So part of what I want to do with Africa is to analyze those spreads also, kind of like okay, here it could be like, this is not a good example. Let's say it could be here, but like it comes kind of straight, but then it has a chunk out and then it comes back. So it's hard to say like where it's trying to stabilize. And so maybe the reality is it's more over at that one. So like if I capture the full range in those instances, maybe it will also shed light. But so he points to the structure, says it bends here. Right. So I found this interesting. And he's right. I think he's right. Everything he points to, I'm pretty sure. Maybe a few of them I didn't really look closely enough to fully be like, yeah, that too. But I trust that based on him finding this, he's really like he's looking. He's not fucking like, oh, look at this, look at this. Wow, it's a wow. Don't you see that, right, guys? Wow, that's such a. Okay, so if I zoom out, where's this angle? Let's get this angle off of somewhere else, off of here. Okay, make sure it's generally. Oh yeah, yeah, it's already. That's what I was getting at. 90. I mean, it's 90. But he didn't mention, and this is interesting. It keeps going. It keeps going. It bends again. Now I kind of, if I keep this line, it's kind of maybe 135, maybe 135. But if I don't keep the line, it's more like 120. So it's almost like it was a hybrid of the two angles occurring. And then I followed this outward, and it's kind of hard to see. It's hard to see, but it looks like it keeps going, and maybe goes through here, maybe through here. So let's say it keeps going. It looks like maybe it bends. Maybe it's because they're not always like exactly straight. Sometimes they just kind of bend. So it's possible, like in the confusion of this region, it kind of bends. So maybe it's here. This is not as distinct, but it does look like it could also maybe be. So if we zoom out, maybe looking for like another corner, like this maybe comes over this way. Like we can kind of see it here. That looks pretty straight line, like that's a continuation of this. And then here, so if I measure that angle, so like, yeah, that looks like that's a continuation of it. So let's put this opposite. This one, opposite. And then up here, it looks like this looks like maybe. So let's just see what angle we get there. I mean, it's gonna be around 120. The more I cheat it over, it's probably gonna be. So that's only 103. But if we look more further over too, like if we use this one and go more that way, it's still. So like that, this would be an instance where it's like, I don't know. At this point, this angle's random. I don't know. I don't know how much I can add to this because it's not like the most distinctly at a polygonal angle that I know of. Like maybe 108, Maybe we can say that's like a pentagon angle, I guess. Maybe that's feasible, actually. Actually, that might be feasible. It's, the more angles I look for, though, I understand. The more I like fill in the gaps and like basically like 112 is 108, and then 113 is 120. So like, look at how they're all like, oh, dude, no. So that's why I was looking exclusively for 120. Then I started noticing 135s. I'm like, okay, that's not random. 108 also not random, but I don't want to stretch too far right now. Also, it kind of looks like you might give it a 90-degree angle there. And then it looks also maybe like it bends here. Like that looks pretty pronounced, prominent. So maybe if we do that, let's see. Bring the protractor out. Put that one there. And then put that one down, just straight down pretty much. I mean, depending on... Oh, that one looks pretty... That one looks way more defined. If that's anything. It just looks like a line. That right there. Like it would be from this process, effectively, and then we can kind of see it here. So it's almost like it's a big polygon. And he's right. I gotta give credit where credit is due. He fucking pointed it out. I had not noticed this polygon or any of this structure. I mean, I certainly knew, like, it's interesting. Like, it's that he talks about this being water cause for sure. Added some details and discussion to things, like over here, the Badlands, this area he pointed to. I think said it was the Badlands. I don't know why it does this so much. Then there's another bend up here. Like here. The way it bends. But I was more focused on Africa, so basically I started looking around Africa. Because if you notice, around Africa, there's a lot more things like this. Boom, boom. Like it's much more like, okay, straight line, straight line, straight line. So like basically a corner and then straight lines. So what I can do, like I was saying, is kind of try to get along the straight line. And just see what angles I can find, like, I mean, to get this to be 120, if I was trying to get this to be 120, let's say, would require a pretty substantial amount. But interesting here, notice this here, it's almost like a tab. It comes here, and then goes back here. And here is this chain that runs through Africa to around this region where this exists. You know, like this exists there. That's interesting. This looks fucking crazy. Like, god damn, dude, what the fuck happened here? Oh my god. Incredible. But so this bends. So I was thinking maybe I would just record. That's why I started recording, was to kind of, I think, was mainly to just record angles, kind of go over this a bit. Like, what I think is happening, let me pull up some other stuff over here. Here's another one, see here. Boop, boop. It's it's crystalline. Here it is. Different materials, and then some sort of. It's almost like I would say like an alluvium that was being like flowed this way during the Cretaceous period. I know it's not alluvium, but like it's like the same type of process occurred where there was just like a so much just maybe magma and things. So this Devonian Mississippian, which was Devonian. Maybe this is related to the Central Atlantic Magmatic Province, because this is the time period after Dwarka was attacked. Gotta understand, Dwarka was attacked pretty much Cambrian, the start of the Cambrian, and then all of this fucking time, all this time happened in like a year. This whole process was like a year. And then it was radioactive decay of the planet because ether was flowed into the planet and it caused it to burst. It just burst and it filled in the space between the continental shelf with a new stable crust, which then water was released from the earth, which flooded the planet, literally swept across here, depositing materials. Swept across. Then it comes sweeping down and pushes up a mountain chain, which it then collides with a wave here, collides with it, spills the mountain chain down, and then the rest of the water over here starts coming across here and just depositing sand because it's running out of other materials, and then leaves this fucking desert, and then it flows out of here into island chains here and here. I mean, some shit's going on here. That then, okay, back to this video. That's right, back to this video. This video. Let's keep watching this. So notice this kind of loses, it starts to open a little bit. Boom. I did not mention this, but I'm seeing it makes perfect sense. Look at where it started. Could it be any more at Dwarka? It starts at Dwarka, goes down between Madagascar and Africa, and then Africa and Antarctica, to basically the tip of South America and Africa and Antarctica, where they meet. Okay, that's around 180 million years ago. So first like the energy, so notice it's around Africa. It went first this way around Africa, and then it went here, and then it goes this way around Africa, and begins to sever this chunk. Basically, goes around this chunk on both sides of it. And then I guess they don't really show it, but I believe when this goes, maybe they'll show it in a second. I don't know why they're showing water here already without showing a crack being formed here. But I believe that this crack actually went around. So it goes down here and around and cuts this segment off. So basically it forms Antarctica in so doing. I'm not sure what this is, if that's Antarctica too. So like first it went here, and then it goes around here, back to here, fully severing this chunk. So this chunk has been separated free. And then it begins to go. So once it goes around there, this chunk is severed. So it's hard for the energy to like go into this region because it's fully separated. So instead, the flow, I guess, went towards the core. So notice what's about to happen. It's going this way, and these things are going to get formed. This thing's about to happen. Boom. Fucking boom. So like the energy's drilling in, trying to flow. It's trying to flow towards the nucleus of the crust. It wants in towards the nucleus. It's almost like gravity. But then it basically, I guess it reacted and it shattered this segment and caused it to be no longer these two. It broke the bond between the two, which recent discovery of the Nader crater is already a Wikipedia article. This crater was found right here. Right here. It's not random position, mind you, because look back at the map. That's right there. It's basically where the three continents were joined. It's literally like a bond was broken. The Earth some way sent energy, and notice. Look at this. Let me show you this. Pardon me. I spoke to this author, and I asked him probably enough questions where he just stopped answering me. Because I'm like, I don't know, guys. This looks pretty real to me. Seismic pull-up processing artifact. They basically say, well, this must be an artifact. I believe. That's what I was trying to. I was trying to find out. Does this have to be are you calling this an artifact because it has to be? Because theory would suggest the crater, this Nader crater from an impact would only go so deep. And so theory says it should be limited to even above where it is. But this is more reasonable. This almost absolutely unequivocally is a artifact according to theory. But according to this seismic graph, it's very distinct. So I wanted to know, is this real? And like, if it's not real, what basis for it not being real? And my thoughts are, look at this. Again, we can do the same thing that I just keep doing. How do I get this bigger? Let's put this one at 0, and then go from this tip. I mean, I gotta make this thing big enough to reach up there. Maybe it's a little off center, but a little. The reason I care about that is, what are the odds if we start finding these things and we're like, well, maybe they're not artifacts, maybe we don't know that they're real and we've just been thinking they were artifacts because theory said so. And all of them tend to be at exactly at right angles, suggesting that they're not impacts, but instead they're emissions from the center of the Earth, which would always be at right angles from the edge of the crosstier, because that's how the process works in some way. I mean, maybe a little bit off center because of being an infinite universe with complexities, but like generally it's pretty straight line there. If it's real. That's why I found that interesting. But so this was recently discovered, and it's a Chicxulub time frame. Like they literally say candidate Cretaceous Paleogene impact crater, and start to say that perhaps an explanation for this is that the asteroid that caused Chicxulub broke up, and maybe there's various explanations what happened. It hit and then it hit again. The next piece came the next year. It came and then boom. So like rapid succession, but not identical time frames. So we're finding this is the thing, 66 million year carbon radiometric dating is not like, it's not random in terms of when a lot of things happen. Like if we notice that Chicxulub happened, then Deccan Traps happened, then Mount Girnar started before then. In further research, I've discovered, and exactly then. Oh my God, Mount Girnar. I've done a lot of research on Mount Girnar. Mount Girnar Susianello et al. Maybe. Nelio. I don't know. This one. It's just. I don't know why I hit download when I have it already twice now, apparently. Hexagon. So what's going on here is Mount Girnar is made of. Mount Girnar is made of a ring of basalt that was emitted from the Earth first. The basalt came first, and then olivine gabbro here, this pink layer, which is really, it's like here. You can kind of see it here, 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 here. You can kind of see it, maybe. But it's not here. It's not all the way out here. This is actually basalt here. But it's here. Surrounding, within a larger hexagon. Or polygon at some points. Like this is more polygonal over here, maybe. But over here it's hexagon. With many parallel lines. So this is formed simultaneous to this Chicxulub. Also, this paper points to another potential crater. Where is it? It's like Boltish crater. Also dated to 65 million years. Chicxulub time. Maybe interestingly, this one maybe was like a chain reaction of the Earth. So like Chicxulub was the first, and then a chain reaction event of many of the electrons of the Earth. Maybe this is what happens: is they're like electrons that become excited and emit particles. And maybe the particles, interestingly enough, nadir, They say specifically Bennu. They say in their paper equivalent to the size of Bennu. What if the Earth emitted Bennu? It emitted it through it. That would be insane. Oh my god! But then like because they're kind of like electrons that maybe they burst like they're excited electrons because our planet was excited because it was attacked by a vortex weapon and allowed ether in that then caused it to grow, balloon to the point where boom it fucking exploded. I mean maybe electrons were excited and boom they blow their top and they emit particles because that's what electrons do. And in our scale there, Bennu is a fucking photon emitted by Earth as one of its electrons emitting a photon. Maybe. Oh my god, I wonder if it has fucking features that are telling. That would be incredible. If like it was a or macrocosm of the microcosm. It was like the best representation of what a photon looks like of all particles that we can see on a larger scale. Kind of like how Mount Girnar is the best representation of the macrocosm on a micro scale. Maybe Bennu represents specifically photons because it was maybe emitted as a result of an excited electron on the planet. Boom, emitted it. Now it's just floating around out there. We're like, that looks about approximately the same size as a comet, asteroid necessary to create this here crater. Because we think it's coming in, but if it's coming out, because I mean, this is not a random position. Not a random position at all. Not random. It's right where like the end of the severing occurred too. Right there. I wonder if there's other locations. Like we could maybe that's a good approach. We could say, well, maybe there's another one like over here on the South American side. Maybe other places have similar impact craters that are formed. So anyway, back to this though. So what I was saying was that energy flowed this way, broke this way, also apparently fractured that way, and then it kind of didn't have enough energy, and so it went maybe this way too. It's again from Dwarkalo, and then cut off the pole. So for some reason it removed the pole of the Earth effectively. It's like this pole, like the energy didn't want to go to the pole, so it wrapped around the pole instead and came back to where it started. I guess maybe it tends towards like the center, the equator, like a gravitational tendency almost of the energy towards the equator. And at the pole, maybe it just wrapped around it, but it conveniently cut it off so it was able to freely move, which is basically what's happening. It's cutting the single landmass into enough land masses that can freely move to then allow for the pressure to be released from within the planet by pushing them apart. But because there was internal pressure, it formed a sphere instead of just like another shape. It just maintained the general shape that it had before. Although maybe if we really studied it, we'd find the Earth's shape before it wasn't even a sphere, and maybe now it's a sphere. Or maybe it's not a sphere and it's flat Earth. Sorry, guys. I really do wonder, like, when I look at shit like that rock I showed earlier, the kettle, this. Like, maybe we are, like, on some object that's just kind of on a flat surface of the sun, which is really like this on a flat surface of something else, so to a point where we can effectively say it's a flat universe and therefore it's a flat Earth. But like, yeah, it appears spherical because of the way that infinity plays with the nature of reality. And so, like, yeah, it's a sphere, but that's like an approximation because really it's a flat universe within that exists at the center, even maybe a flat Earth, maybe on the center layer, like the layers here. Okay, back to this. So then this works like this. Not only does it work, it fits in with what the Dwarka analysis I had in the Mount Girnar video, and it adds more detail. Whereas, like, simultaneous to this happening, the Big Bang is highly under. I keep running into YouTube videos. The Big Bang never happened. Like, they're clickbait. They're all saying the same shit, but they're saying it now. It's like a wave, an onslaught of the Big Bang never happened. Like, it's getting some attention because the James Webb Space Telescope is not benefiting the Big Bang model. At best, it's like neutral. Maybe it can be argued to be having a neutral effect on the Big Bang model, but the reality is it's basically yet again disproved the Big Bang, and this time more rigorously and just more concerningly, really, to the point where it's starting to fracture the models and sever them into smaller components so that they can be restructured and rebuilt into a new system. And right now, it's just doing that. Whereas when I encounter this, I'm like, dude, thank you. See, that's the difference. I'm like, thank you for more information that adds, that clarifies and makes things clearer to me so that I can know that, yes, there's something to what this, that. Yes, thank you. That's what this does. Whereas James Webb Space Telescope, disproving the Big Bang. That's just how it goes. And this more, it's really disproving plate tectonics, because now plate tectonics, it doesn't give a shit about these angles. It's like it literally is happenstance. Well, of course it would have angles, and like if energy travels in a 90 straight line, then it's generally going to be off of that angles that are generally off of 90 or 180. So like, yeah, so at times it's going to be angles that are like 120ish. I mean, that just happens. That just happened. Nothing important. So let's see. Okay. So what else did I notice of interest? So now I'm at around 117. We notice the other side of Madagascar being severed. It's starting to open. It's starting to open. Push Africa northward into Europe to cause the Alps, the second wave of mountains over top, overwriting the first wave that the Appalachians wave caused there. And notice how this, if I watch this again, this region doesn't really change shape much. It kind of drifts. It just kind of drifts until, just watch. 66. Boom. Now we got some shit going on here. Wasn't this just the edge? Why is there a fault line between the edge and the edge? Isn't it like, if we were to go back, it was here, between continents, not between the edge and the edge. If there's a fault line occurring here, that would be strongly suggestive that there's some shit going down here. Not that there's a fault line being formed. Let's keep watching. 84, so it's still kind of like, okay. Okay, so these are, that's interesting. So it formed a channel. So gotta understand. Maybe I should pull up a plate, expanding Earth map. Something like this. Cretaceous. Basically, it formed a channel from. Fuck it. Where's a good image of this? I just need one of those like this. Let's show James Max. Well, alright, is it max low? I always do that. This one. This one. Okay. So basically, if we look here, there's not much going on except for at the Pacific. That's where we see color. Indian Ocean is starting to open. It's hard to see what's going on here. Okay, there's Africa. There's Africa. So that's Africa. So it's starting to open between Africa and India. Yeah. But especially already, like a, mind you, at this 120-degree angle is where it's occurring. Line this up here. Oops. I don't know why it does that. And then line this up here. I mean, it's absurd. How some of these are like. Every time I do it, I really do get like. Because the reason is I think it's clean. It's precise in these places. Because 120, when it happens, maybe it happens because of like just a fuck ton of energy. Like it takes a lot of energy to do 120 angles, maybe some reason. Something about it. There's something about it where when the Earth expanded, it caused a 120-degree angle there and then shoved energy off of it. So pushing into the Pacific. So like carving this way, basically, between here. Carving, because this is all closed. This is all closed. This, basically, Antarctica, India. India's up here. Antarctica is up here. It's like here, let's say. And Australia's over here. And so, like, literally gap closed. And then the channel that comes off of here goes this way through. That's why there's this. That's why there's this here. This literal wave. Because the channel, it was carved this way, wrapped around, and started to put pressure into Asia, basically, especially, which is why what we're going to see here happen. Boom, just right there, right at that, like, boundary. The Cretaceous boundary with whatever. I don't even know. Paleo? Fuck, man. Why'd I even try? And then notice this starts to take shape. This starts to become more and more like that fucking wave that it actually is. Because this was just kind of best guess. They just had some shit there, and now it's kind of taking that shape. This whole region is not well understood or well established as what they show it as being. And then we're to basically modern day. And here we are. And what got me looking at this is because this is the East African Rift Valley video, was this. And then I found this interesting. So like as it's doing this, right, it's then this fracture here, I guess the energy is flowing still this way. It's almost like it's trying to cut across to the Mediterranean to complete this severing. And so suddenly it does it. Boom. Just to complete the channel. Like it wants to be completed. Otherwise, this shit is two together and it just fractured. And then in comes a flow, I guess. Like the way it showed it was almost like it went up this way, down this way, and boom, all pretty much simultaneously. Sudden, very sudden. Right, 24th and 29, around 20 million years, according to radiometric dating, which is not valid because it's based on a constant decay rate, which has been shown to be seasonally dependent. So we literally cannot use radiometric dating as an absolute age. It's unreliable for that reason. It's very reliable for a relative age, so we can be like, okay, this is the sequence that occurred. But the absolute age, it's not true. It's literally all of this took a year. This took 1 year to occur, to go from being a here to here. And all this shit happening. Mount Girnar. And in the process, just many things occurred. Many things. Many things. I guess I didn't really measure angles, but let me just measure some angles. Let's see what's going on here. This one looks like I could probably align it off of these there, maybe. That looks pretty decent. And then maybe this way. There's 120. I mean, it is kind of... thereabouts. That's kind of... it's too rounded sometimes to really be able to do this thing, what I'm doing. Although that's interesting. Look at that. This one, I've had different measurements in the times I've measured it. So if I put it along this edge, and then along this edge, let's say 45 for now. That's pretty close to 45 from this point. That's the thing, is I can also be like, well, I mean, clearly it's more like a 60-degree angle. That's still pretty good. It's still less than random. Or it's more like or I could be like, well, it's more like a 50-degree angle. That's pretty random to me. So this one's not the most telling, not the most. That's the thing, is like it requires the angle being precise enough that we can at least be like, okay, that is this angle. And then look at the ones that do have those characteristics and say, okay, since that is this angle, and that one is this angle, and that one is this angle, and that is this angle, then we can say that this angle is occurring more readily than we would have expected otherwise, to a point where we see there is some sort... it's almost like a crystalline nature to the Earth that's occurring, where it is a crystal. It's got crystal blocks that occur. which is why it has these like shapes like this going on. Oh my god. Whoa. Interestingly, also, I saw this. If you look over here, you can kind of see these features. Like they're kind of covered by the sand. Like, where'd they go? Because those are very common here. That's why I find them interesting. They look a lot like these. They don't they don't look like the traditional just river kind of shape. That's the thing. They don't look like that. They look more like lightning. See, like, here's a river, like there. Let's find more like that. That does not look the same as these. These are like tendrils. I mean, maybe water flowed in those ways. Maybe. I mean, it does look kind of like it. I just wonder if energy flowed in those ways. And then water now flows in those ways because that's water just following the path that it followed. But, like, there was something more substantial here that's just buried. Everything, there's probably a lot of shit buried here. Like, a lot of shit, dudes. I believe I measured this also. Let me see. As being 90 degrees. So, like, if I kind of go here, maybe. Okay, that's certainly not 90. And then maybe follow this lake to that other lake, maybe. Like around there. But actually. Okay, maybe not. I mean, this bends. So it's a little anomalous considering the things I've been looking at. Let's just look at them real quick rather than measuring them. See, you can see them. I guess I should, while I'm looking at them. This one's so distinct. I might as well just see what it is. I mean, it's pretty much 120. So you can see it much more distinctly than like here. Like maybe this is a corner, maybe up here for sure. It's hard to say anything because I'm looking at the continental shelf. I don't care about this. This is not what's important. What just happens to be a water level, the shape that it takes. Although maybe there are things that it tells that I'm not considering. But what to me is critical is where, like here, like none of this is very easily measurable. This is not measurable. Angles here, not measurable. Not measurable, not measurable. Maybe you can kind of see a line there, and maybe there. So, like, maybe I could do that angle by doing like that. And then like that. So maybe that's like a 45-ish degree angle, but it's not defined. Like from a scientific standpoint, there's nothing I can really point to here that's like, okay, look at this angle. This angle, like here maybe is again is just hard. It's just hard to define in a lot of places because it didn't fracture as straight liney. Like here maybe I could say, okay, this is here to here. So let's maybe do this one. Anywhere where it's like maybe looks like it's reasonable to do it. Here, I gotta remember to do it like that. And then maybe there. I mean, that might be like approaching a 90-degree turn. But like, let's see. I gotta find some really defined ones. That's not defined enough. This is more like, so like, here's a little, this is where that nadir crater is, so it's hard, maybe there's a little confusion here, like maybe this goes more here. But it's hard to say what the straight is here. But this one, and you can kind of say is right there, maybe in there. So we can measure that angle pretty good. Just be like in there, maybe. And then maybe there-ish. It's pretty close to 120. It's pretty close. This one, maybe it's more like 135. That would be interesting. I do commonly see them like with one another. That could be approaching a 30-degree bend. But 30, I'm not looking for 30. It's too many. It's really, this one's hard to tell because you can see it kind of bends in and back. But if we were to say it goes from maybe here to here, then that, I mean, it's hard. This one here, there's another potentially 150. Let's say. Why is this? I really wish it would not do that. Okay, there. Let's say maybe put it at the same line. And then do this one more like along. It's not quite, it doesn't really straighten until down here. That's just not good enough though. Although it looks like if we really, it's possible that this is more like a 150. Like it goes 150 and then bends a little bit, and then goes 150 there. I don't like 150. It's the thing with these numbers that are too high is they're also, I was thinking about it, literally, they're more likely to be like a higher error bar. Because effectively off of, what matters is how far off of the straight they bend. Like if it's going straight, then boom, 90 degrees, like that's pretty uncommon. But if it's going straight, and then boom, 1 degree, like, is it 1 degree? Is it half a degree? I don't know. Like, where's the start and end? I don't know. Like, it's not as easily measurable. Like, for instance, Flemish cap. Here, like you can see, straight line, straight line. That's interesting. It's similar angle. No, I don't think it would be relevant to what I was just looking at. Maybe there is for that side, and then maybe start from about there and go up this whole length to about there. I mean, it's. I don't want to make it 90 degrees, but it is. Why does it freaking do that? Oh, well, maybe there's something there. Right there. Like a fucking crater. Crater. Looking if there's any, maybe that. Any actual maps of anything underneath Flemish Cap. Orphan Basin and Flemish Cap Pass. Cretaceous, Jurassic, Cenozoic. Crustal, Jurassic, Cretaceous, Cenozoic. I don't know. I'm not sure how studied this region is, honestly. Ooh. 2007. Get access, dudes. I posted on Twitter to some journals, telling them off practically. Stop charging $40 for your fucking article. What the fuck is this shit? Purchase. Look at this. $35. A whole book purchase. $200. 7-day access. What are you selling? Gold? You guys are fucking ridiculous. Fucking ridiculous. They're literally not even the authors. That's what pisses me off. This society is not the authors whatsoever. It's these people who are not getting $200 for 7-day access for this. You know, like they're literally just using and abusing these people in the name of their prestigious things, whoever it may be, anytime. It really fucking irritates me because then I have to find a way to maybe get lucky and find this article. It's as simple as that. Request. So, like, I can ask these authors, hey, could I get your article? That's better than some of them because you literally cannot even do that in a lot of places. Maybe I should be requesting when I run into this. I never actually request when I run into them. I'm like, yeah, fuck that. That might have it. Buy this chapter. It's like, dude, do you or don't you want people? Like, look at what I'm doing. You think I want to pay $30-some when I randomly find this fucking article? It's literally absurd. Nor can I. Even if I wanted to, I can't. I don't have fucking money for that shit. You guys are charging absurd prices. I mean, more than a penny is is too much. A penny is too much. The fact that you're asking for money for information is too much. Unless I was wanted a physical copy, like something that costs money to produce subsequent copies, the portion that goes to me. But because it's just a fucking article that anyone can read, it doesn't really do anything except limit society to make it so I can't access this. Unless you get your fucking paycheck. Like, oh, dudes, no, that's not actually helpful. Because you're not even the authors. You're fucking thieves at that point. At some point, we go from prestigious to thieves. And I think we're crossing that line real quick. New York Times. Let's check out what they have to say on today. Oh, wait, what? Limited articles, free, log in. Oh, you gotta fucking log in, give them information. Not free. Or unlimited access, $1 a week. Are you saying you guys are so good that you deserve mandatory payment? No thanks. See what happens? Their prestige melts away because they fucking are not that prestigious. They're literally sources of propaganda on top of that. That's the thing. Like, this is intentional propaganda. The people behind it frequently know that they're intentionally lying. Maybe not always. Sometimes the authors are not aware that someone above them wants them to lie for a reason. But that shit happens on the regular with these fucking charging for the lies. The audacity. The fucking audacity. And then these fucking college prestigious, oh, we're academics, we're leaders of the thinking of the world, and what we think is best is that you pay us $40 a pop for a 24-hour access. Are you fucking kidding? Jokes, dude. Let's see what they got to say. Seismic reflection, refraction data reveal the large-scale structure of a magma-starved rift margin. Little evidence for significant extensional deformation of the Flemish Cap, consistent with the hypothesis that it behaved as a microplate throughout the Mesozoic. Okay. Yep. So they're saying, that sounds to me, behaved as a microplate. Like, it was maybe even above sea level. And maybe when Atlantis was sinking, but yet to have sunk. Asymmetries during the final stages of continental breakup and the onsets of oceanic seafloor spreading. $30 kilometers thick to 3 kilometers thick over a distance of 80 kilometers. Anomalously thin began accreting to the margin. Data suggests there are large spatial and temporal variations in the available melt supply following continental breakup as oceanic seafloor spreading becomes established. In addition, wide-angle data show that anomalously slow mantle P-wave velocities appear approximately where continental crust has thinned to 6 to 8 kilometers, indicating that low degree serpentization begins where the entire crust has become embrittled. Oh dear God, I wish I could read this. It's not like I read every fucking word. That's the problem. They want $36 so I can look at the figures. Maybe read more. Like it's literally that's how I'm not reading every word of the fucking papers. That's the thing, dudes. It's not how research goes. Let's see. Ooh, this one gives me some actual seismic data for free. See? Not $36. So why would I ever give $36? It makes no fucking sense. These people are out of their minds. It's almost intentional elitism and like limitation of information causing an artificial scarcity. Well, we printed the magazine. We did all this work to make sure we peer reviewed and brought in the best of the best. We deserve $36 a pop. Are you fucking kidding me, dudes? Don't you got enough fucking funneling academic subscriptions from institutes that get fucking dead enslaved children to pay all their fucking funds? You don't got enough from them. You gotta grab $40 a pop for some fucking casual reading of an article. Like, watch how I read this. Think I should have paid $40 for this? Come on. You guys are out of your minds. Let's see. It's literally not the authors. That's what's annoying. It's not the authors. Whoa. What the fuck? Computed. Oh. I thought that was some real shit. What are they? Wait, what? Is this some real shit? What the fuck are they showing? I'm gonna have to look at this later, I think. This looks... see whatever that was. Why not? Anomaly. Oh, here we go. Oh, I'd have to read this closely. Okay. Okay. That's probably enough. I just thought I'd talk about some of that Earth angle stuff and what's going on lately. I would highly recommend also. Let's see what. Let me just make sure before I stop here. Pictures of Mount Girnar rocks. Literally. Angles, baby. Angles, baby. Another rock. Let's see. See, this one is easy to get an angle for because it's more distinct. I mean, we can already see it's like exactly 120. Obviously, this is a picture, so there's that side of things, which is also interesting. Like, if this is a thing that happens where, like, from this dimension it's 120, but from another dimension it's actually 45-degree angle. Like the real angle is. Let's put this in there. 120. Interesting rocks. I thought this one maybe looked interesting enough to post. Some like tendrils. I look at these as kind of like the fingers of a spiral galaxy that are flowing through some dense material. This here, there's like bumps, bump, bump, bump. It's rounded but then stepped. A lot of this going on, I'm not sure. The two colors. This rock here I found real interesting. It literally has a bunch of peaks. It looks like a mountain chain, but on a rock. Data tray a peak. Not more rocks like that. Like this shit is incredible. Oh my god. I got new pictures too that I haven't posted. Here, the water, places water flows. Like, look at that. Oh my god. Just sharp angles. Sharp faces. You want to say erosion did that? Oh yeah, erosion just cleaved exactly this whole length. It's absurd. It makes no actual sense if you really think about it. How the fuck does this rock right here exist? Erosion is not sufficient. Maybe they have better explanations than I realize, but effectively, what I get when I point to these things is erosion as the answer from geologists. So, I think it's absurd. It's fucking absurd. If you really think about it, I see why we would answer that way offhandedly, but like if you really think about it. Water flowing through here. Mount Girnar. And then there's a Shivaling that emerged of its own divine intention right here. Somewhere around here, maybe it's here. I think it's there. Not actually in the hotel, but in here. What's in a name? A bunch of stuff about its name. Several names. One of its names, Kalisa Gire. Kalish Gire. Its first names, according to this dude who I trust fully, because his research on Girnar is so... I'm so happy it exists. This dude has spent like decades researching Girnar from a an Australian perspective, so it's kind of unique, but thoroughly scientific. Like a lot of information, inclusive that one of its first name was Kailash Kiri, which is currently the name of another mountain, and it means crystal mountain. Crystal mountain. You know, like shaped in like being a crystal. Literally being a crystal. crazy. Okay, guys, that's all I got. Thanks for checking out this video. Till next time. Oh, and I hope the world doesn't end in the next few days. I'm really honestly, it's September 22nd. Putin's talking about nuclear war. Who knows what the fuck's going on there? Who knows what's going on? Russian nukes can be. Kremlin warns. Stock market also. Dow Jones. Oh, it did close down. It went below. It went below 30,000. I think like physically people like that it says 30 and not 29, and they want like they. It's almost like a control tactic where they feel that to control people, people feel it is better off that it be a 30 than 20. As soon as they see that 29, the concern raises that we've dropped below 30,000. But because we haven't, it immediately faced resistance and hasn't been back below again today. We'll see what the future holds, but I strongly suspect that that's more of like a built-in resistance, where if it drops below this value, then we do this, that, and the other thing, just like high frequency trading kind of thing to control the market to a point where it keeps it looking pretty. It's all like they literally try to brush it off, make it look pretty. That's how they behave. Let's make it look pretty. It's not, it's fucking trash, but make it look pretty. Literally, until the system collapses from the stupidity of it all. Honestly, maybe we should change things as soon as possible and as orderly as a way as possible, like turning these armies into farming armies, literally, into like cleaning armies to like clean this fucking world up. That's what we really need. Not some fucking military to go destroy shit. Not no more. Those days are past, dude. Because look what's about to happen. Who knows? Who knows? And it's about that time, guys. September 21st through like the 30th. That time of the year, since I've been doing my research, since I suddenly spontaneously quit my job and have been paying attention to everything going on in the world as much as possible, and obviously not everything, every detail, but like as much as I can, the world events according to like the news and all different angles. You know, when things seem to like pick up without any intention of my own, like I'm not like seeking like a sudden outburst of events, like just like world events in my experience tend to suddenly grab my attention in this time frame in ways that are more pronounced than like other time frames where it's kind of like this, where like a bend is occurring, there's like a change in the state of the energy where like a new equilibrium is maybe not even reached, but like it's a bump in the road that yearly we come back to the same bump, and maybe it's adding activation energy each time until then enough energy has been input to then have the reaction proceed to then cause a new equilibrium. So maybe kind of like, for example, like a bend is occurring. This maybe not the best place to show it, but like sudden bend, and then like how it's curved. Sure, let's just say it keeps being curved. And that's a little sharp. Not as sharp as some of these. Keeps being curved. Like this one. This one's so sharp. Sharper, maybe. I guess not as sharp as that one little one that I was really looking for as the best example. And maybe some other places like here and Flemish Cap. Like sharp bends where they then stabilize. Okay. Maybe that's what's going on, so there's that. There is that. This information will change the world, so I'd appreciate it if you share, like, subscribe, pass it along. Thanks, peace out.